Before the Apollo missions, before humans walked on the moon, there were the pioneers. These small, fragile spacecraft marked humanity's first bold attempts to break free of Earth's grasp and explore the unknown. In this video, we'll journey through the story of the pioneer missions that pushed the boundaries of technology and paved the way for future exploration. From the thrill of first launches to the lessons learned from setbacks, the Pioneer series laid the foundation for America's path to the stars. Join us as we explore how these early spacecraft transformed humanity's dreams of space into reality. This is the story of the pioneers, the first steps in our journey to the cosmos. Before NASA was born, before humans dared to dream of stepping on the moon, there was Able 1. Later known as Pioneer 0, this was humanity's very first attempt to break free of Earth's orbit and send a spacecraft to the moon. The year was 1958. The United States was eager to lead in space exploration. Only 6 months after the launch of Explorer 1, America's first satellite, the US Department of Defense unveiled plans for a series of lunar probes. One of these, the first of 3 attempts by the Air Force, would make history as the world's first deep space launch. The spacecraft, built by Space Technology Laboratories, was a modest 84-pound conical structure. It was equipped with cutting-edge technology for its time, a magnetometer, a micrometeoroid detector, 2 temperature sensors, and even an infrared TV camera. Ingeniously, its surface was painted with dark and light stripes to regulate temperature during its journey. On August 17, 1958, from Cape Canaveral's Launch Complex 17A, the Thor Able rocket stood poised to make history. The mission aimed to reach the moon in just 2.6 days, after which its payload would enter lunar orbit. But fate had other plans. Just 73.6 seconds after liftoff, disaster struck. A turbopump gearbox failure caused the Thor rocket's first stage to explode at an altitude of 9 miles. The spacecraft itself transmitted telemetry for a few seconds longer, before falling into the Atlantic Ocean. Investigators traced the failure to a mechanical issue in the rocket's turbopump. Despite the mission's abrupt end, it marked an unprecedented leap toward exploring the cosmos. Although Pioneer 0's journey lasted less than 2 minutes, it sparked a legacy. This mission laid the groundwork for the famed Pioneer series, which would later explore the outer planets and beyond. Every great achievement begins with a first step, even if that step falters. Pioneer 0 may not have reached the moon, but it was the first bold stride into the vast frontier of deep space exploration. After the US Air Force's attempt with Pioneer 0, the space race was heating up. Just months later, in October 1958, a newly established agency called NASA launched its first ever spacecraft, Pioneer 1. Pioneer 1, originally designated as Able 2, was nearly identical to its predecessor. Weighing just 84 pounds, this small yet ambitious spacecraft carried instruments designed to study the moon and the near-Earth environment. The spacecraft's payload included tools to measure radiation, magnetic fields, and micrometeoroid impacts. It also featured a TV camera to capture a facsimile image of the moon. Every element was meticulously crafted to provide groundbreaking insights. On October 11, 1958, from Cape Canaveral's Launch Complex 17A, the Thor Able rocket carrying Pioneer 1 thundered into the sky. For a moment, it seemed as though NASA was about to make history. But just like its predecessor, the mission faced challenges. 10 seconds too soon, the Thor rocket's second stage shut down. A malfunction in an accelerometer caused incorrect data to cut off the stage prematurely, leaving Pioneer 1 without enough velocity to escape Earth's gravity. Engineers attempted to salvage the mission by inserting the probe into a high Earth orbit, but low internal temperatures drained the batteries, and the plan failed. Despite not reaching the moon, Pioneer 1 soared to an impressive altitude of over 71,000 miles. During its 43-hour mission, the spacecraft collected critical data on the Van Allen belts, verifying their existence and expanding our understanding of the Earth's geomagnetic cavity. The data returned by Pioneer 1 was invaluable. Although the mission was short-lived, it showcased NASA's determination to push the boundaries of human knowledge. The name Pioneer was officially given to the spacecraft after its launch, suggested by Stephen A. Saliger, an Air Force official overseeing exhibits. The name perfectly encapsulated the spirit of exploration that defined this era. Pioneer, the 1st of May, not have achieved its lunar goal, but it succeeded in something just as critical. It marked NASA's first step in space exploration and laid the foundation for future missions to the moon and beyond. From every setback comes a lesson. For NASA, Pioneer 1 was proof that failure is never the end. It's just the beginning of the journey to the stars. After 2 bold attempts to reach the moon, the United States made a 3rd try with Pioneer 2. Launched on November 8, 1958, this mission aimed to orbit the moon and continue humanity's journey into deep space. With lessons learned from its predecessors, Pioneer 2 featured several upgrades. Its spacecraft mass increased to 87 pounds and carried enhanced scientific instruments, including a new cosmic ray telescope to study the Cherenkov effect and a reconfigured TV system. The launch vehicle, the Thor Able 1, also underwent modifications to improve performance. At 7:30 UT, from Cape Canaveral's Launch Complex 17A, Pioneer 2 roared into the sky. However, the mission encountered a series of mechanical failures. First, a ground signal prematurely shut down the Thor rocket's 2nd stage, causing insufficient velocity. Then, as the X-248 3rd stage separated, it failed to ignite due to a broken wire. With no chance to escape Earth's gravity, the spacecraft re-entered Earth's atmosphere and burned up just 42 minutes after launch. During its brief flight, Pioneer 2 reached an altitude of 951 miles and managed to transmit valuable scientific data. Its findings revealed surprising details about Earth's equatorial region, including higher than expected flux and energy levels, as well as a denser concentration of micrometeoroids near Earth than in outer space. Despite its short mission, Pioneer 2 contributed to the growing foundation of space science. Officially named after launch, it became another stepping stone toward understanding both our planet and the cosmos beyond. The Pioneer missions were not just about reaching the moon, they were about learning from each setback. With each attempt, NASA and its partners grew closer to achieving their goal. Pioneer 2's story reminds us that even in failure, there is progress. The path to the stars is never a straight line, but every step brings us closer to our celestial dreams. December 6, 1958. A small spacecraft named Pioneer 3 stood ready on the launch pad at Cape Canaveral. Unlike its predecessors, this mission wasn't led by the U.S. Air Force but by the U.S. Army, marking a new chapter in America's quest to explore the moon. Pioneer 3 was a spin-stabilized probe designed to rotate up to 400 revolutions per minute. Once in space, 2 small weights would extend outward on wires to reduce its spin to just 6 RPM, ensuring precise measurements. The spacecraft, though only 13 pounds, carried remarkable technology. Among its instruments were 2 Geiger-Müller counters, used to measure radiation levels, and an optical sensor designed to test future imaging systems. But as history would show, its contributions would go far beyond its initial goals. Pioneer 3 launched aboard a Juno 2 rocket early on December 6th. The mission aimed to fly past the moon and enter a heliocentric orbit. However, just 4 seconds of miscalculation would change its fate. The Juno 2's main booster engine shut down 4 seconds early due to premature propellant depletion. This error left Pioneer 3 traveling 640 miles per hour, short of the escape velocity needed to reach the moon. Instead, Pioneer 3 reached a maximum altitude of 63,580 miles before succumbing to Earth's gravity. The spacecraft re-entered the atmosphere 38 hours later, burning up over Africa. While its mission to the moon failed, Pioneer 3 made an unexpected and monumental discovery. The spacecraft's Geiger-Müller counters recorded crucial radiation data, confirming the existence of dual radiation belts encircling Earth, now known as the Van Allen belts. Dr. William H. Pickering later described the mission's findings as a dividend of radiation measurements. This data redefined our understanding of Earth's energetic environment and opened new paths for protecting future spacecraft and astronauts. Although Pioneer 3 never reached its destination, it proved the importance of perseverance and the unexpected value of exploration. Each setback brought new discoveries, reminding us that the journey itself can be just as impactful as the destination. Through its brief journey, Pioneer 3 made history, not by reaching the moon, but by uncovering secrets of our planet, proving once again that exploration is never without reward. In March 1959, the United States embarked on its final attempt in the Pioneer series to reach the moon as part of the International Geophysical Year. This mission, Pioneer 4, carried not only scientific instruments, but the hopes of a nation eager to cement its place in the space race. Designed similarly to its predecessor, Pioneer 4 included a new feature, a voltage monitor for the main radio transmitter, addressing a critical failure from Pioneer 3. At just 13 pounds, it was equipped with Geiger-Müller counters to measure radiation and an optical sensor for imaging the moon. On March 3, 1959, the Juno 2 rocket launched Pioneer 4 from Cape Canaveral. Unlike the missions before it, this spacecraft achieved Earth escape velocity, marking a historic first for the United States. Although it successfully escaped Earth's gravity, Pioneer 4 passed the moon at a distance of 37,000 miles, nearly twice the planned range. This was too far for its imaging scanner to function, preventing it from achieving its primary goal of photographing the lunar surface. While it missed the moon, Pioneer 4 transmitted groundbreaking data. It confirmed changes in the intensity of the Van Allen belt since Pioneer 3, likely due to a recent solar flare. Even more intriguing, the data hinted at the existence of a potential third radiation belt. After transmitting for 82 hours, setting a new record for communication distance, Pioneer 4 became the first American spacecraft to enter heliocentric orbit. This achievement was a pivotal moment in the United States' journey to explore beyond Earth. Though it didn't capture the moon, Pioneer 4 reached a destination far more significant. It became a true pioneer, escaping Earth's pull and proving humanity could explore the vast reaches of our solar system. The early Pioneer missions were stories of ambition, setbacks, and triumphs. These missions laid the groundwork for modern space exploration, proving that even in failure, there are lessons to learn and milestones to achieve. From verifying the Van Allen belts to becoming the first American probe to escape Earth's gravity, these early pioneers charted the course for humanity's journey to the moon, the planets, and beyond. As the Pioneer spacecraft ventured into the unknown, they carried with them humanity's unyielding spirit of exploration. Their legacy reminds us that every great journey begins with a single, courageous step.